Aerospace Engineering. Introduction. Aerospace engineering is a field focused on the design, development, testing, and maintenance of aircraft and spacecraft. It encompasses both aeronautical engineering, dealing with aircraft, and astronautical engineering, focused on spacecraft. Aerospace engineers work on a wide range of projects, including airplanes, helicopters, missiles, satellites, and spacecraft. Key areas of focus. Aeronautical engineering. This branch concentrates on vehicles operating within Earth's atmosphere, such as airplanes and helicopters. Astronautical engineering. This branch deals with vehicles operating outside Earth's atmosphere, such as spacecraft and satellites. Aerodynamics. Studying the motion of air and how it interacts with objects in flight. Propulsion. Designing and developing engines and other systems for propelling vehicles. Structural design. Ensuring the strength and stability of aircraft and spacecraft structures. Guidance, navigation, and control. Developing systems for controlling the movement and trajectory of vehicles. Avionics. Focusing on the electronic systems used in aircraft and spacecraft. Materials science. Selecting and utilizing materials with appropriate properties for aerospace applications. Main courses. Aerodynamics. Aerodynamics is the study of how air, or other gases, moves and how objects, such as an airplane wing, interact with that movement. It's a branch of fluid dynamics focused on the forces exerted by air on objects moving through it, and vice versa. This field is crucial for understanding and designing everything from airplanes and automobiles to skyscrapers and even sports equipment. The term aerodynamics is often used synonymously with gas dynamics, the difference being that gas dynamics applies to the study of the motion of all gases, and is not limited to air. The formal study of aerodynamics began in the modern sense in the 18th century, although observations of fundamental concepts such as aerodynamic drag were recorded much earlier. Most of the early efforts in aerodynamics were directed toward achieving heavier-than-air flight, which was first demonstrated by Otto Lilienthal in 1891. Since then, the use of aerodynamics through mathematical analysis, empirical approximations, wind tunnel experimentation, and computer simulations has formed a rational basis for the development of heavier-than-air flight and a number of other technologies. Recent work in aerodynamics has focused on issues related to compressible flow, turbulence, and boundary layers and has become increasingly computational in nature. Materials science. Materials science course, also called Materials Science and Engineering, is an interdisciplinary field that explores the relationship between the structure, processing, properties, and performance of materials. It's a field that draws from physics, chemistry, and engineering to develop new materials and improve existing ones for various application. Aerospace structures. Aerospace structures course focuses on the design, analysis, and construction of aircraft and spacecraft. It covers topics like structural mechanics, materials science, and how to apply these principles to aerospace vehicles. These courses are crucial for students and professionals in the aerospace industry, preparing them for roles in design, analysis, and manufacturing. Thermodynamics. Thermodynamics typically covers the fundamental principles of energy, heat, and work, and their relationships within physical systems. It often includes an introduction to the laws of thermodynamics, property analysis of substances, and applications in various engineering fields. Many courses also delve into topics like entropy, exergy, and specific applications such as power cycles, refrigeration, and combustion. Propulsion. Focuses on the principles, design, and analysis of systems that generate thrust for vehicles, particularly in aerospace and marine applications. It typically covers topics like thermodynamics, fluid mechanics, combustion, and different types of propulsion systems, for example gas turbine and rocket. The course may also delve into specific areas like aircraft performance, control systems, and emerging technologies. Guidance, navigation, and control, GNC. Guidance, navigation, and control focuses on the systems that enable vehicles, particularly autonomous ones, to navigate and operate effectively. It covers the design and implementation of algorithms for guidance, setting the desired path, navigation, determining the vehicle's current state, and control, executing commands to achieve the desired path. Flight mechanics. Flight mechanics is a course that explores the principles of how aircraft move and interact with the atmosphere, covering topics like aerodynamics, propulsion, performance, stability, and control. It involves understanding aircraft flight conditions, equilibrium, and the effects of aerodynamic and propulsive controls on these conditions. Students will also learn how to analyze aircraft stability, model flight characteristics using computational techniques, and potentially even simulate flight. Avionics. Provides specialized training in the electronic systems used in aircraft, including navigation, communication, and flight control systems. Avionics refers to the electronic systems used on aircraft. Avionics systems include communications, navigation, the display and management of multiple systems, and the hundreds of systems that are fitted to aircraft to perform individual functions. These can be as simple as a searchlight for a police helicopter or as complicated as the tactical system for an airborne early warning platform. What does an aerospace engineer do? Aeronautical engineering. Aeronautical engineering focuses on the aircraft design, development, and testing within the Earth's atmosphere. As an aeronautical engineer, you can work in the areas of aerodynamics, the study of air movement around objects; aircraft structures; propulsion systems, engines; flight mechanics, how aircraft move and control; and avionics, electronic systems in aircraft. Each of these areas has been described before. Astronautical engineering. Astronautical engineering focuses on the spacecraft and launch vehicle design, development, and operation, including rockets, satellites, and probes. Spacecraft design refers to the designing and creating spacecraft for use in space exploration and research. As an astronautical engineer, you can work in the areas of spacecraft structures, propulsion systems, orbital mechanics, how spacecraft move in space, space environment, and satellite communications. As a whole, aerospace engineering is a highly multidisciplinary discipline that includes a number of specialist fields. These fields fall under the headings of aerodynamics, propulsion, structures, control, and spaceship design. Each of these subfields specializes in a particular area of the design and development of an aircraft or spacecraft and necessitates a thorough comprehension of the fundamental concepts underpinning physics, mathematics, and materials science. Thanks for watching. For more videos, please like and subscribe.